I want to talk a little bit about how we can put those technologies to better use and actually really get them out into the wild in a way that really hasn't been possible in the robotics industry. Robotics, specifically in industrial manufacturing, really got started in 1956 when at a sort of a mixer, a guy named George Duvall, the namesake of this conference that we're at, and another gentleman got together and thought about how to build the world's first mass-produced industrial robot. And that robot that they ended up building was called the Unimate.
A robot for industry.
So this robot was the first of its kind from the standpoint that it was much more versatile than any other robot that had ever been built. Most of them were sort of relegated to the lab or the research institute, but this could actually get out in the world, manipulate objects in a repeatable fashion, and do really exciting things. This came out originally in 1961. It made a huge splash. It was on the Johnny Carson show. They showed cool demos of it pouring drinks and playing golf and conducting the band, all of this really amazing stuff, right? So it seemed at that moment that robotics was poised for this amazing future, right? Where you had these systems that for the first time could finally do the type of tasks that people had struggled with for the last 100 years since the beginning of the Industrial Revolution, things like lifting 60-pound castings all day long or working in toxic environments. And then this was the answer, right? So this was 61. We're close to 50 years now in the future. So let's say where we are today. And we're kind of in the same place, right? Now, I'm not going to say that technology has not improved. It 100% has. Right? That robot is faster, stronger, and better than anything that has ever come past it. It's more accurate than a human could ever possibly be. It's a different color, right? And the tasks that we do on a daily basis are also very similar. Like, we still need to move around metal tubes to make things in this world, right? So our need for these robots hasn't changed, but we're still sort of stuck in the past, right? We even do the same demos. Right. This was from this year's this year's Automate conference, right? Beer pouring, right? And we're close to the 50th anniversary of pouring robots with beers, right? That would be like going to CES and making a big deal about a computer that can add. So what happened? What happened? And switching gears to computers, why did such a promising technology as robotics sort of not see the future that we now enjoy in the information age, right? This was 77. The first mass-produced computer also came out in 61, the IBM 650, right? IBM spent the next 15 years improving on that technology, but computers still sort of were this mainframe type system. Very complex, very complicated, very single purpose. It took the invention of the personal computer to really drive the space of computing, right? Not only because now you had these simple devices that the everyday person could use. Right now, your mom sitting at her kitchen table can balance her checkbook with a computer. That was something that 10 years ago was impossible. But also, it created a huge surge in the computer industry, right? The 80s was a real hotbed for computers, growing linearly, right? At the same time, because it was such an exciting space, there was a huge number of companies that got in. There's like 40 or 50 separate personal computer companies that had different architectures, they had different programming languages, all sorts of stuff. It was super messy, right? Well, that changed in 81 when Microsoft released DOS, and then a little later when it released the first version of Windows, right? And immediately you see this massive consolidation. All of these different technologies that are out there, all of the different platforms, they consolidated to two, almost overnight. Right? And that drove the not linear expansion of robotics, but the exponential expansion of robotics, which is why today there's probably at least 500 computers in this room. Right? So how did computing do this? And why was that single red line there such a big deal? And what can we learn about that in the robotics space? Well, these are really the three reasons that this consolidation happened. Right? You have a common operating system, right, which for the first time actually commoditizes the hardware, right? You have these computers, they're all running the same thing, which means the prices go down because consumers now have choice. You have a developer ecosystem that's actually enabled because you can write one application that runs on more than one computer. Imagine that, right? You have hardware standards that make the nuts and bolts problem of the computer industry go away, right? You didn't have to reinvent the plug for your mouse every time you plug it into your computer, and that's literally what we had to do in 1979. And then on top of that hardware and software platform, that common platform, you had applications designed for the end users that actually provided real value to real people. Programs like VisiCalc, which was then eventually replaced with Excel, Word, things that let consumers see the benefit, end users see the benefit of computing, which drove massive adoption, right? Again, robotics today, right? This is the robotic mainframe. And this is how it's been for the last 40 years. In the last 40 to 50 years, we've only automated 10% of manufacturing, just 10. That's it. Only 10% looks like this. Only big factories, and surprisingly, it's amazing to go into a big factory and see how few of them are actually automated like this. Right, 10%. This is what most of manufacturing looks like. It's people putting pieces of metal into machines and taking them out again when they're a different shape. Right. And a lot of these people are super highly skilled. Right? This guy, he's at one of our factories that we have our products in. He's been doing this for 30 years. He knows all the tricks. He is a genius in making that machine build a super high precision part for the aerospace industry. Right? Like it's amazing what he's capable of doing. But we don't seem to be leveraging him. Right? When we think about a robot, we think, well, either it can't do this task, or it's too complicated, or it's too expensive, or it's too hard. Well, what is driving that? What is driving that mentality? The other thing that I want to mention is all of the trends are pointing towards automation being more and more and more necessary. Right now, I could go into all of the stuff about onshoring and made where you buy and mass customization, all the trends that are making automation more necessary in the world. But just look at this graph. All this is saying, and the only takeaway from this, is that more wealth is being created in the world than ever before, right? Especially in emerging demographics. And what that means means more people on this planet are living like us, right? They're becoming consumers. They're joining the middle class. They're have leverage to actually buy goods. This kind of graph scares me. And it scares me because our manufacturing layer on this planet is completely incapable of dealing with this growth because it can't grow as fast. 10%, remember? If we doubled the amount of consumers on the planet right now, we'd be hosed. Like, we just would not be able to build enough stuff. Prices would skyrocket. That would be it. So how do we unlock that? How do we make that manufacturing and that automation get into the market faster and actually start changing problems? All this amazing technology you guys have been hearing about in robotics is still sort of feeling a huge amount of friction when it actually goes out and tries to solve real problems. So what is that? Well, it's not the cost of the robots, because that's going down, right? This is a graph of the average cost of an industrial robot. We eclipsed the cost of people in 2013, right? And it's just been getting cheaper and cheaper and cheaper. So now it is cheaper to employ a robot to do a task than a fairly skilled person at a factory, and yet we still aren't automating fast enough, right? The robots have gotten better. They've gotten safer, right? These are the cobots that you were chatting about, right? All of these robots are very inexpensive, they're fast, they're durable, and they're human safe. And we've seen a mild uptick in the adoption of robotics, right? Just like we saw in the computer industry when the PC came out and we saw an uptick in the number of computers that were being bought, right? But the problem is because we now have this huge amount of interest in the field and we haven't solved the fundamental problem, this is what the robotics market looks like. It's a mess. It's hugely fragmented. This is just like half of the companies that I could, call automation and robotics companies, right? End users don't know where to start. The only people who can deal with this ecosystem are very skilled robotics engineers and automation engineers, who there are a paltry few of, right? Considering that there's 12 million people that work in manufacturing, there's about 30,000 engineers. That's like 1 for every 10 factories in the United States. 1 person. And we haven't solved the usability problem. Remember PCs? Remember how they were easy to use, right? That teach pendant over on the right-hand side, that's from the state of the art, right? This is 2019 technology, and it looks like it's from the 80s, right? And when you actually go to put this thing together, this is what it looks like. This is what you have to do. You get the robot, that's cool, it moves around, awesome, right? How do you put all this stuff together to make it actually grab something, or sense something, or manipulate an object, or hold any type of precision, or get mounted to the floor, right? Somebody has to build all that stuff. That'd be like saying every time you want a new laptop, I'm going to give you all of the parts to build it, and you're just going to build it. Now, I know some people like to do that, but that would be like ubiquitous. Everyone. That's the only way you can buy a laptop, is just, here's your parts. Have fun with that. Oh, and it's a different programming language if you buy a Dell versus if you buy a Gateway, or a Gateway, sorry, Compact, right? You know, something. When you think about this problem, this is a universally understood problem. Like, this is from a great McKinsey article, which I can find and share to you guys. But the idea is like, these are the two things holding us back. Why is this so hard to program? And why is there not a common interface? Why is there not this for robotics? At Ready Robotics, that's exactly the problem that we're solving, right? We are solving the very difficult and kind of unglamorous problem of creating the picks and shovels that we hope the rest of the robotics industry will eventually be built on. Because without a platform, without a common piece of technology that all of these robots are running or that work on, you are going to keep wasting effort. The friction is going to stay hugely high to get anything into the market, and you're going to keep solving the same problems over and over and over again. So these are our three products: Forge OS, Forge Control, and our Task Canvas. Forge OS is an operating system. It is like Android for robotics. It has an application layer, so you can write one application and then it works on any robot you want. It has a hardware abstraction layer so that you can take a gripper or a camera or any type of sensing device or a communication protocol and use that on any robot. That's all stuff you have to handwrite code for right now, in most cases, to get it to work, right? So this actually enables the developer ecosystem that we want to build, that we can eventually build this industry on top of. A hardware layer, right? Because you have to have the hardware too. This is the physical box. This is the plug-and-play hub, the Forge Control box, that lets you actually plug those cameras in and plug those grippers in and have them just magically work, like when you plug a mouse into a computer, right? It just works for you. And then finally, Task Canvas, which is our first killer app. This program lets anyone, and I mean anyone, program a robot to do anything that you want. It takes the person who is sweeping the floor at a manufacturer and turns them into a robotic engineer overnight, because we based our very simple building block interface on what people are used to in manufacturing. They're used to looking at flowcharts. And we have figured out how to very smartly encapsulate the complexities of the robot, into these very simple human-readable building blocks, right? Any person, any robot, any application, and any developer, right? Notice I keep using the word any, because that's the promise of a platform, right? There's no compromises. And that is what this industry needs. For all of the technology that we're talking about here to propagate out into the world, we have to solve the nuts and bolts problem. We have to stop building the pedestal that everything else is built on over and over again. And because of this parallel, we know that an operating system like Forge or like Windows will solve those type of problems, will commoditize the hardware, will democratize the programming so that anybody can do this, and that robots are accessible to not just people with PhDs, right? We know that the industry needs a Microsoft, and at Ready Robotics, we think we are it. Thank you.